Welcome to homework.
In this problem, we have just a beam that's supported by some bearings at each end, so they don't provide any moment. And then there's a uniform distributed load over the entire length of the beam. And now, just from symmetry, we know that these two need to be equal, and they need to carry half of this total load. So this is going to be WL over 2, and this is also going to be WL over 2. Now, if we look at the shear, we can see that it's going to vary. It's going to vary from WL over 2, and it's going to decrease linearly as we take more and more of this distributed load into consideration as our cut changes. So it's going to decrease from WL over 2 to minus WL over 2, and it's going to be 0 in the middle here. Then the moment is going to be quadratic, and it's going to be 0 at this end, and it's going to vary with x squared, because the moment here, if we take a cut here, the moment is going to be related to the area here, which is related to x, and also the centroid, or the center of this area, which is also related to x. So we're going to get a value here of let's see here, it's going to be so this was minus W over minus WL, or minus WX, minus WX squared over 2. So we can see that it's 0 here, comes up, reaches a peak at the center, and then drops back down to 0. And again, we need to make sure that that's the case because we have no point moment here. Now the second part of the problem actually is to just put in some values for these. And when we put in some values, you can see that this plot and this plot this plot looks identical to this, and this looks identical to that. And the only difference is that we have different scales on the axes. And so when we put in values of W equals 500 pounds per foot and L equals 10, you can see now we go from 0 to 10 instead of 0 to 1. And we reach a peak moment here of about 6,000 foot-pounds. And again, they look identical. And so here we have let's see here, that would be 5,000 over 2, 2,500 pounds on each of these loads. So again, they look identical, it's just the scales are changed, and that's because V goes like W times L, and M goes like W times L squared. So if we knew what M over WL squared was at this point here, this is I think 0.125, and then multiplied it by W, which is 500, and L squared, which is 100, we would get this value of 6,000.